Guitars have been a prominent instrument in the music industry for its ability to be flexible when it comes to producing different sounds. The simple logic that we understand about guitars is that in order to create music, the only things that are required are correct finger placement across the neck and hitting a couple of strings. Rarely do we take the initiative to ask ourselves how these distinct sounds are created and what the physics behind every strum is. Soon enough, you'll learn how guitars make sounds while taking into account the physics that is happening. When it comes to acoustic guitars, sounds are generally produced whenever the guitar strings vibrate. This vibration occurs by picking the string and it travels through the saddle that it rests on, then to the bridge which rocks back and forth on its axis, to the soundboard, and then finally to the sound hole, which amplifies the vibrations into noise that we can hear. At any point in the air near the source of sound, the molecules are moving backwards and forwards, and the air pressure varies up and down by very small amounts. The number of vibrations per second is called the frequency, which is measured in cycles per second, or hertz. The pitch of a note is almost entirely determined by the frequency. High frequency for high pitch and lower frequency for lower pitch. The strings on a guitar are ordered from thinnest to thickest strings in the sequence of E, B, G, D, A, and E. In essence, the thinner the string is, the higher the frequency and pitch is, and vice versa. In the world of electric guitars, the method that sound is produced is much different. Unlike its acoustic counterpart, electric guitars have solid bodies and do not have a sound hole to project sounds. Electric guitars have what are known as pickups, which are placed underneath the strings next to the bridge where strumming and picking occurs. When the strings of an electric guitar vibrate, the vibrations are electronically sensed by the pickups and then route the signal to an amplifier and speaker in order to produce sound. In this diagram, this pickup consists of a bar magnet wrapped with as many as 7,000 turns of fine wire. Understanding how electromagnets work, we know that the coils and the magnets can turn electrical energy into motion and vice versa. In the case of an electric guitar, the vibrating steel strings produce a corresponding vibration in the magnet's magnetic field and therefore a vibrating current in the coil. There are many different types of pickups, such as this one, which has a separate pole piece for each individual string, like the one in this diagram. Some pickups use screws for pole pieces so that the height of each pole piece can be adjusted. The closer the pole piece is to the string, the stronger the signal. The pickup's coil sends its signals through a very simple circuit on most guitars, which can be depicted in this diagram. The upper variable resistor adjusts the tone. The resistor and capacitor form a simple low-pass filter together. The filter cuts out higher frequencies. By adjusting the resistor, you control the frequencies that get cut out. The second resistor controls the amplitude of the signal that reaches the jack. From the jack, the signal runs to an amplifier, which drives a speaker.
On the Gibson guitar factory floor, workers have sawed and sanded wood into the iconic shape of the Les Paul guitar. But here in the electronics department, it's time to get amped.
Think about an acoustic guitar. When you pluck a string, it causes the entire front of the guitar to vibrate, and we hear those vibrations. But what if you want to amplify that sound so that it could fill an entire stadium, for example? You'd use this, a pickup.
Each pickup consists of a solid magnet with a coil of wire wrapped around it over 1,000 times. When someone plucks a string, its vibrations cause a change in the magnetic field, which produces an electric current. This current runs through the coil and into a wire that's plugged into the guitar. When the current is amplified and sent to a speaker, we have the sound of rock and roll. Workers install the pickups on the guitar's body so that the strings will pass directly over them. Once they mount the pickups, they then install the control knobs. These allow the guitar player to interact with the electric current as it exits the guitar. One knob controls the signal's volume and the other the tone. Now that the guitar is wired up for electricity, workers can add the strings. First, they screw in the bridge, This is what holds the strings in place on the guitar's body. These strings are made of steel. That's because steel can create vibrations that will register in the pickup's magnetic field. Finally, with the strings in place, the Les Paul electric guitar is complete.